variable. So for storage resource, we have quota per namespace, and we also have quota per storage class. So if you look at this table, the first two is per namespace. So basically, you create a quota object in your namespace, and you can specify requests. That means across all PVCs, the total storage requests, like how many gigabytes, cannot exceed this value. And you can also limit the number of PVCs in that namespace. And also, since we have storage class, so similarly, for each individual storage class, you can specify how much storage you must restrict, and also how many number of PVCs you can have per this storage class. And so for snapshots, I think we can have some kind of similar concepts. We can have quota for per namespace. We can have quota per we call snapshot class. And so for namespace, you can restrict how many total number of volume snapshots you can exist in this namespace. So I think that should be straightforward. But for requests, if we have a request for snapshots, then we have a little bit issue here because we don't know exactly how much snapshot takes up the storage. We only have a restore size, which is the size of the volume that you take snapshot from. So whether we should have similarly like a request snapshot in quota or not, I think this needs some discussion. And this is per namespace, and then we can have per snapshot class. And since snapshot class and storage class are different.
Can you hold on a second?
Sure.
I'm trying to understand. You're referring to a quota related to the size, like the consumed space of the snapshot?
Yeah. Yes.
Okay.
From the,
I was going to say, generally speaking, that can be a very hard number to compute.
Yes. Yes. So that's why I think we might not be able to do that. But whether we can have something like, since we have a restore size, whether we should have a quota for that in like, it's basically, okay, you can take snapshot for this much storage.
What's the use case? What are you trying to prevent?
So it's just like, you don't want to take too many snapshots, but
right. So if you have a quota on the number of snapshots you can take, but not the total size,
yeah.
What is the bad case? It's somebody makes a really, really large volume and then takes the maximum number of snapshots of that large volume, and
yeah, kind of like that. So it's not very clear, actually. Yes, I agree. So we can first just give total number of snapshots per namespace. I think if that's good enough, then we can just have that part. We don't need really have the like requests snapshots like total number of restore size.
Okay.
Yeah, I'm just like suggesting whether we should have similar quota or not. So,
well, but there's going to be two quotas, right? Because you're going to have this snapshot quota, and then when you convert it into a usable volume, it's going to fall under that other quota, right? You're still thinking that?
Actually, that's a good question. So I think snapshots and storage can be separate quotas. So because here we have snapshot class, right? You have storage class. And for system admin, if they want to set up quota, they can kind of have a rough idea, like if they have total 100 gigabytes storage, they want to have 80 gigabytes for storage, like volumes, and 20 gigabytes for snapshots. And then they can have quota for snapshots. But if we don't want to have this like a storage request concept, then we can only limit the number of snapshots. Then that's very two different concepts, right? So you just limit whatever number you want to have the number of snapshots instead of the size of the snapshots.
I think it makes sense to have request.snapshot because that gives a way for admins to set an upper bound as far as what percentage of their storage can be used for snapshots, what percentage can be used for data. So and also back to Ben's argument that you cannot calculate snapshot sizes correctly. I agree. It's based on the type of backend. Snapshots may consume more space or less space, but one can say the same thing about volumes. Volumes based on whether they're thin provision, whether they're deduped, whether they're compressed. What you end up on the storage backend is quite different than what a user may think. So I think in that context, it's okay to use the request.snapshot as a way just to upper bound what percentage of storage can be used for snapshots or not.
Yeah. So I think upper bound is it's something kind of a good use case of this, right? Even though the snapshot might not.
The problem is that basically these snapshots are coming from the same storage pool as regular volumes, and admins want to be able to control,
Right.
what percentage of it should be allocated to snapshot or not. So that's the way to do it.
Right. So in that sense, I think we might not use a different name, like it's not really a request for snapshot. So I say restore size for snapshots cannot exceed this total, this number. So like you said, it's provide upper bound for the total storage that's consumed by the snapshot, although snapshot may not take that much storage. So this is for per namespace, and we can also have per snapshot class. And the concept would be similar. So you can restrict the total number of snapshots and also the storage, like the resource storage that snapshots can takes. So another thing we are also thinking, this is per namespace, per snapshot class. How about per volume? Whether we should provide a way for user to specify, like they can only take this number of snapshots per volume. And if you already take, let's say, more than that or equal to that, you cannot take any more unless you delete some.
The problem you're going to have here is if snapshots are not linked to the volume from which they came, you have no way to compute this number. Like the volume could be gone. Although I guess you can't create more snapshots in that case.
That could be a problem. The only thing that I'm kind of concerned about is, do we have some like concrete use cases for some of these things? Because it almost seems like we're just trying to think of any possible feature or any possible quota that we can add, as opposed to thinking about things that people might actually want or use. You know what I mean?
Yes, the concrete use case. I think the general idea is just like we want to give user a way to kind of restrict how much storage they can use for snapshotting.
Okay.
But, yeah.
So if that's the case, then it would seem to me that the only one of these that's actually really important is capacity usage, right? I mean, which is the hard one.
But it's also the way we handle volumes today, right? Like, I mean, I think what they're trying to get at is some consistency with the way we already manage it in Kubernetes. And it's not perfect because, like Ardalan said, it's not true to what's actually happening on the back end in the storage. We don't have a way of enforcing that, but it's at least a way for an admin to restrict a user creating an unlimited number of snapshots and keeping that size reasonable. I mean, it's fundamentally broken prior to this without having the enforcement with the actual physical storage. So,
yeah, to be clear, I'm not proposing that we shouldn't restrict it. I'm just wondering if we could narrow the scope a little bit and focus on the concrete.
okay, so in a typical storage, like outside of Kubernetes, if I'm an admin managing snapshots, do I typically restrict those today? I mean, how is it done outside of this? What are those use cases look like? And are we trying to mimic those same use cases that an admin would want to manage their storage in a non-environment?
Well, in a lot of cases, what ends up limiting usage is cost. So if people have to pay for the bytes used, they'll sort of limit their own usage. You know, if they're paying for the storage itself. But if you're providing a service to someone else and you don't have a good way to bill based on actual usage, then something like quotas does provide ways to prevent bad actors.
Yeah, and there's two things that I've experienced in the past in terms of quotas and limits, right? And usually the limit in terms of a number of objects, like number of snapshots, that usually comes up due to device behaviors or API limitations or something like that. Because for the most part, the only thing that is really of concern is sucking up all of the storage resources on the back end, right? So it's a capacity thing as opposed to, and in using things like count or number of snapshots doesn't really mean anything, especially if, for example, if your snapshots are deduped, right? And you take a snapshot every hour, but there's no changes on your system. You could have hundreds and hundreds of snapshots, but they're all actually, there's no actual consumption. So, I mean, I know those are kind of silly things to think about, but.
Yes, then for volume, we also have the number of volume quota. Similarly, right, the volume could be super small. So I just thinking there should some system like might care about if you have too many of those, even though the total size might not really big, but they still don't want you to create that many.
Yeah, you're right. You're definitely, I definitely agree.
Right, so we basically just provide some mechanism, like then how user use it, like depends on their environment. But those two, like number, one is the total number, the other is the size, seems a common like use, common way to like restrict.
Yeah.
So I think since we provide this for volume, and so far I think I don't hear any like major issue related to that. And I think for Snapshot, we can follow the same pattern, so user can use it in a very familiar way.
Yeah, I think you're right. I think that following the same pattern and being consistent is probably the safest way to go.
Right. And so I think for per namespace, per snapshot class, we don't have much like issue, right? So we kind of agree we provide these. And how about per volume? So I'm thinking this kind of for user side, they might want to prevent themselves to forget, like take too many snapshots for a particular volume if we provide this, but it's might not that critical, yeah.
So there are some storage backends that have, there are some storage backends that have limitations as far as number of snapshots per volumes. But given that in Kubernetes, the lifecycle of snapshots is completely independent of the volumes, this may confuse users to make this association between snapshots and volumes. I don't know.
So I mean, if we provide this, it might confuse users, or?
This one seems like it's in the gray area, and I would say probably, given that it's not following an existing pattern, and there's no clear reason to do it, and the confusion that Arlon mentions, I would say you can always add it later. I would leave it out of round one.
Yeah.
Well, there is the pattern for this. We do this today in Kubernetes. We do have restriction by storage class per namespace, whether or not it can be used in that namespace. So there is.
The per storage class, the per namespace, sure, but the per volume seems like one that could be left out because there's no obvious reason to do it, and no pattern that it's following.
There are storage backends that have this restriction. Right? There are some storage backends they just can take only a certain number of snapshots per volume.
That's true.
Yeah. So, but well, maybe
but
we could.
You could. I mean, I see both sides of the argument, right? But it does seem to me, I kind of agree with Ben that it seems like it would be okay to leave this one out for the first pass at least, because the other thing is the driver can still respond if they have a specific limitation and say, hey, I can only create 100 snapshots of volume, and you asked for 101. Sorry, delete some snapshots or do something else, whatever. I mean, it's not like it's an insurmountable problem to solve.
I think that's good enough for provide first two, and this leave it for now. And so yes, so the backend will return some error message, and right now it will publish to the user, and user can understand. Okay, they just delete some more snapshots before they take the next one. Okay, so seems like we settled on the storage, the snapshot quota, and so we will follow the same pattern as PVCs. And anyone think this is critical for like moving to beta, right? It might be P1, P0, or so maybe let's leave it to P1. Is that okay?
Yep, sounds good.
Okay. And I also added something to the list. Go back to the deletion protection. So last time we talked a few scenarios, but I think we forgot one more scenario is, since we have two API objects, volume snapshot and volume snapshot content, similar to PVC PV, and user might delete volume snapshot content while it is still binds to the volume snapshot. So for PVC, I think we added a feature to add finalizer, so you cannot directly delete PV, the volume, if it still binds to PVC. And currently, if you delete it, it will fail, and the status of PV is called terminating, but it's not actually deleted. And until I think the PVC is deleted. And so for volume snapshot and volume snapshot content, I think we probably need the same protection. So otherwise, the volume snapshot still binds to this content, but this content object is gone. So we can have the similar protection, use the finalizer. So until like volume snapshot is deleted, we cannot delete the volume snapshot content. Any questions about this protection?
Makes sense to me.
So Jing, the finalizer for the PVC and PV, the way it works is that while the volume is in use by a running pod, right? That's when we delay the deletion of the PVC and
Ardalan,
PV.
there's two finalizers. So one is between PV-PVC and one is between PVC and pod.
I see, okay.
Right, so we do add a protection between PVC and PV. When they bind to each other, you cannot just delete PV first.
And,
okay.
And didn't we already talk last week about the case of while a volume is being created from a snapshot, you would have a similar kind of protection. You couldn't delete it until the volume was done creating.
Yes. So
that would be analogous to the PVC pod finalizer. You know, don't delete the snapshot while someone's using it to create a volume.
Right. Yes. So I think that's the second.
That's the
delete
third
volume
bullet.
while it is being restored, and the third one, delete volume while it is being taken snapshots. And at that time, we say this is kind of a P2 feature we want to add. Yeah. So the
Seems
first,
pretty important to me. I don't know.
Oh, you mean the second one, the third one is important?
Yeah, for sure. Yeah.
Okay, so then we can say these deletion protection for the first three scenarios, we can make them like as P1. So we want to make sure these features are implemented before we move to beta.
I think that's okay. One more thing I wanted to talk about was a retention policy. I think I commented a little bit about this on the blog post, but currently it sounds like the default retention policy is to delete the snapshot when the objects are deleted. We don't appear to have any retention policy. Is that in the works? Is that something that we want?
Right, this is the next item.
Perfect.
I called reclaim policy, right? So right now, yes, we don't have anything like policy. Basically, if user deletes volume snapshots, API object, and everything is deleted, including the volume set content and the physical snapshots. And for volume, we do have a reclaim policy, right? You can call the recycle. Maybe that one is no longer supported, but we have delete and retain. So even though you delete the object, but the physical volume can still you can still keep it instead of delete it. So for snapshots, we can have the similar policy. One is called delete, the other called retain. Delete means if you delete API object, right, the volume snapshot, everything is deleted. And but if you want to have a retain policy, so then only the API objects will be deleted. But you want to keep the physical snapshot around, yeah.
I thought that the analogous thing in the PV-PVC world was retain meant the PV actually hung around and could get rebound. Am I misunderstanding?
Yes, the retain, so here I say only delete the volume snapshot object, but keep the content object and the physical snapshot around.
So you do keep the content object. Okay, you said there was something around we could delete the content object, but keep the actual snapshot on the storage controller, which made less sense to me.
Okay. So I mean, here, these two policy for the retain, we do keep the volume snapshot content. Yes.
Okay. And in any situation where the volume content object is deleted, it's expected that the actual snapshot is deleted too.
Whether we can have that, currently we don't have protection. So I think, like I said in the first item, the deletion protection, I think when the volume snapshots still bind to each other, if you just delete the API object, the content API object, there's no protection. Like the API object will gone, but the physical snapshot will be still exist. But we want to prevent that. So after we add the deletion protection for that, so yes, I think we can make sure the content still exists.
Okay.
And only if the physical one deleted, the content one will be gone. Yeah. Currently, we still have this problem. Yeah, the content might be gone.
So the goal is to mirror what happens with PVs and PVCs. Is that what I'm hearing?
Yes. Yes.
Okay.
So, so for these two, right? After we have these two protection, the deletion protection and the reclaim policy, then we will have better control of the life cycle of those. So, yes. Any questions about the reclaim policy? So it's quite similar to PVPVC.
Well, I guess my only beef is the name makes a lot less sense with regard to calling it reclaim, because with the PV you obviously have a way to reuse it. You can delete everything and then go use that for something else. With a snapshot, there is no way to actually reuse it. I can imagine reasons you would want to keep it around, but calling it a reclaim policy is a little bit funky, because you're not actually going to reuse it for anything. You're just leaving it there for in case of emergency.
Say you reuse it, right? For example, so you delete from one namespace the volume snapshot, but the content and the physical snapshot still exist, and you create another volume snapshot in a different namespace and binds to it.
Sorry.
Okay.
My understanding was once once the PV is in retain and the corresponding PVC is deleted, it can no longer be bound to a new PVC. And I would think it's same here, right? Look, once you have a
Yeah. So yes, the volume, that makes sense because volume will have data. So the user first, let's say the first user like write some data to that volume, and you do want to have protection. This volume will be used by another user. But actually, if we move on to the next item, so I'm thinking snapshots in a way that's quite different from volume, because snapshots, you are not like write any data to it, right? The first user writes some data and the second user should not access it. But snapshots depend on the kind of sharing policy, like how admin set it up. Then the user might want to use it, share it across different namespace, or different user might share these snapshots. So even let's say you delete from the one namespace, but you do want to use it in a different namespace. If we say after the snapshot binds to this one and you no longer use it for any other snapshots, it seems too kind of restricted for snapshots. And for snapshots, it's sharing seems kind of a good use of snapshots, right? You might want to create volume.
Yeah, but when you delete the volume snapshot object, then the system will, in response to that, delete the content object automatically, right? That's what's supposed to happen. So
Yeah.
what prevents that? You're saying you set the policy?
Yeah, the reclaim policy, right? If users.
But I thought the reclaim policies were not modifiable. So like if it's the reclaim policy is delete, then it's always going to be that. And there's
You can change the reclaim policy after the creation of the object.
okay. So to satisfy this migration or namespace change use case, you would temporarily change the reclaim policy to something like retain, and then
you can just when you create, you want to use this policy, or after you create, by default, I say it's delete, but you change it to reclaim and just keep it like that.
So one thing though, there is a, so you can run the patch command and change the reclaim policy, but I did notice in the current documentation that that's listed as deprecated. So I don't know if that's something to consider or not.
It should be marked as deprecated only for the recycle policy. The other two policies should be supported.
Right.
Ah, okay.
We have 3 policy actually, yeah.
okay, so you can't recycle a snapshot, obviously. But you're saying you could, if you had one that was marked delete, you could change it to retain, and then you could do this namespace swap trick, and then after it was in a new namespace, you could change the reclaim policy back to delete, and it would be just like it was in the new namespace.
Yeah, and that's exactly the way it would work today with PVPVC as well.
Okay.
Yes.
So,
yeah, go ahead.
I think we're somewhat abusing the retain policy here to enable the sharing right now. Are we counting our reclaim policy to be the mechanism to enable sharing, or do we want to be able to support sharing without using the retain reclaim policy? Because I can see, I mean, users don't have to delete a volume snapshot in order to enable sharing. I mean, they may want to use a snapshot themselves and also share it. So I don't think this should be the mechanism that facilitates sharing.
Yeah, it's not a mechanism for sharing. It's just, I don't know, sometimes users just want to delete the API object, but keep the snapshot around. And I don't know exactly why they want to do that, but some users seems to have a use case of that.
Yeah, it's not the primary intent of this feature to be the mechanism by which you share. One of the side effects is that you could do that, but the primary purpose here is just to be able to ensure that the snapshot is not deleted if you don't want it to be deleted automatically.
Yeah, so I look at these as different topics. We should investigate each separately.
Yes, I agree.
We shouldn't tie them together. Yeah.
Well, and it sounds again like what we're proposing is to mirror what happened with PVs and PVCs again. But at the beginning of this, Jing, you said you see it very differently than PVs and PVCs. So I don't see how it's different after we make the statement that it's going to have the same policies as PVCs.
When I say different, I'm thinking probably related to the sharing.
The sharing. Okay, the sharing is the different part.
Right.
Okay, and it is a separate concern than this reclaim policy.
Yes. So the policy itself, right, is similar to PVPVC, the reclaim policy itself. But the naming maybe, like, as you said, I'm not sure since this is the same pattern with PVC, so that's why we use reclaim. But it's not, I'm not sure whether it is a good way to say for snapshot 2.
Well, it sounds like the PVC one it's deprecated with regard to the recycle, and I think it's recycling that is most confusing. So if that's going away,
right,
maybe both names should be changed, but you don't want to rock the boat there. So.
Right. Can we say it's retain policy? We provide the retain policy.
Yeah, I'm usually all about consistency, but in this case, I think retain might make a little bit more sense.
Well, but retention typically has a different connotation in the context of snapshots. In the context of snapshots, you talk about snapshot retention with regard to like a snapshotting schedule that is taking snapshots and automatically taking and automatically deleting snapshots, and the retention is how many you tend to keep before you delete the oldest one.
Right. That's a good point. So then maybe just to keep it clear, let's leave it as reclaim policy because that, as far as I understand, doesn't have any other connotation.
Or deletion policy. It's related to the delete.
I actually like deletion policy because that would make more sense for PVCs as well. If we were to change it.
Mm-hmm.
Yeah.
So any other suggestions or? Okay, so I think the purpose of this policy, right, is mainly to prevent sometimes to automatically delete the objects. So I think deletion policy also makes sense. We can currently use deletion policy for now, unless someone have like other ideas. Okay, so we can move on. Yeah.
Sure. I've had this question for the past 2-3 years. I think now is the right time to ask. So when you set the retain policy for a PV to retain, set the reclaim policy to retain, that leaves the PV around. And the only way one can consume the data corresponding to that PV is to manually create another PV with the same content, right?
Mm-hmm.
And have a PV bind to it, right? This is the only way somebody can make use of that volume again in Kubernetes. Is that so?
I don't think so.
So after,
I think that's accurate. You'd have to clone that volume and create another one. The idea of the retain policy was if a company said you had to keep the data around for 12 months or something, you could put it in retain and it would sit there and it'd be up to the administrator to clean it up. Does that answer your question?
Right. Yes, it requires manual intervention by the admin to, whether it's for auditing or for any other purpose. But if, let's say, somebody accidentally deletes the volume and the reclaim policy is retained, the only way one can reuse that volume is to manually create PVs and that has the same content as the
Yes, and that is on purpose.
original.
The idea is the default behavior is all automatic. There is automatic provisioning. There's automatic deletion. If you explicitly opt out of that, then you're opting into a manual process. And if you don't like that manual process, you can always change the policy again back to automatic.
Okay. I mean, the reason I'm asking is because we have customers who are asking, how to prevent accidental deletion, things like that. And this is what I've been suggesting to them. I just want to make sure this is the actual workflow.
Yep, that's the intention.
Okay, great, thanks.
okay, so kind of related to this policy. So I'm thinking about for snapshot, like I said, sharing seems very useful. For volume, in most cases, you don't want to share volume like across different namespace or users because it contains like the user's data. But for snapshots, you might have, let's say, some snapshots and you want to use it in different scenarios, like one is for testing, one is for development in different namespace. In some cases, different user might also want to share this snapshots. And right now for volume, right, we have this 1-1 mapping between for volume, PVC and PV. And I'm thinking why for snapshots it must this way if sharing is useful, since for snapshot, for example, you have a physical snapshot and you have a snapshot content for that. And currently, if you want to use the same snapshot in different namespaces, similarly, you need to manually create another snapshot content. right?
So I disagree that the difference has anything to do with the data inside the volume of the snapshot. I think you can make the same arguments about, you know, people wanting to share data in a volume that you can for a snapshot. I think that the salient difference between them is the consumption model. Most volumes are the, you know, read write once, not read write many.
Mm-hmm.
You know, for a read write many volume, you could make the argument, sure, lots of shared across namespaces, lots of people mount it and attach to it. There's no problem with that.
Mm-hmm.
With snapshots, there's sort of a default and anyone can use it, and so it's automatically shareable. I think that's the important difference to think about.
Right.
Is that there's no concept of read write once with snapshots.
Yes. So my idea is currently, if you want to use snapshot in different namespace, right, you need to manually copy the content object and then use 2 volume snapshots object to bind them. And why not we just have 1 content object corresponding to that snapshot, and you can have some policy in this content. If it's,
Well, hold on. Go back a second. You were saying you could create 2 volume content objects with pointing to the same snapshot, but that's going to cause problems when you delete one of them and it actually deletes the underlying snapshot. What would prevent that?
yeah, right now it's possible. Yes.
So that doesn't seem like a reasonable
Wait, can you
workaround.
clarify that? Is you're saying that 2 volume snapshot objects can bind to a single content object?
No. So you can have 2 content objects.
Okay.
It's point to the exactly same underlying physical snapshots.
Okay, got it. So, but they're separate objects.
Yeah. So for volume, we have the same thing.
Right. Yep.
You can have PV that point to the exactly same volume.
But it's a sketchy thing to do because deleting either one of them will delete the underlying storage object, right?
Yes. Currently, there's no protection for that.
Okay.
But maybe you have you raise a point that we should think about, since 2 PV point to the same volume. If you delete one, we should prevent the physical one is deleted, since the other one still point to that. But currently, we'll do any protection.
Why wouldn't we clone that one and then make it so it can be cloned, and then it creates a new volume so that we don't have this chaining going on? I mean, I assume the assumption is you create a snapshot and you want to give it to someone else within that namespace to use, or possibly in a different namespace. And you don't necessarily want to have the same retention policies. You want to be able to update that snapshot based on what you're running. So why are we chaining them together? Or am I misunderstanding?
I thought that the use case was I want to have a snapshot and I want to share it with everybody, not a specific user, but just say, hey, here's a snapshot. Anyone in the system can potentially access it. But how do you make that happen?
Yes, so we are discussing.
But access it simultaneously or access a copy of that?
There's no reason they couldn't be accessing the actual snapshot simultaneously.
Yeah, I think maybe depends on the underlying storage system, but you can, let's say, create volume from snapshots, multiple volume from snapshots. It depends on the underlying system, like how it can be done parallel, or it should be done sequentially. But you can have multiple volume, right, taken, restore from the same snapshot at the same time. You can have such request.
So that assumes that we're just reading from that snapshot, though, and we're not writing to it. Is that a fair assumption if you're going to do the simultaneous access?
That's what I understand, yeah.
I thought snapshots were defined to not be writable, so that's an easy assumption to make.
So I haven't been following the discussions on volume cloning and sharing volumes across namespaces. I think it makes sense to have a generic mechanism to share objects across namespaces. So whether it's volumes or snapshots, it all works the same way. And I think rather than just focusing on the snapshot use case and the fact that it's read-only and there can be many-to-one mappings or whatever, I'd rather be focused on the larger pattern of how to export objects from one namespace to another. And whether there are snapshots or PVs, doesn't matter. It's the same mechanism.
I agree. And I guess I thought, though, that we would leave snapshots the way they were, and snapshots weren't technically usable till they were promoted to a volume. And if we fall underneath that same mechanism, then we can restrict the cloning to the volume piece. And it can be snapshots or just, snapshotting a volume that didn't happen to be a snapshot.
And I thought the other advantage of that approach was, well, not other advantage, but to re-articulate exactly what you were saying. The advantage of that is you don't have to worry about the linked cloning or the links to the volumes and stuff like that. So we would just create a volume from a snapshot, transfer the volume to the other namespace, and then there's your volume. And if you want to make your own snapshot from that point on, then you can do that.
Yes.
Okay.
So here, it's just like kind of thoughts about sharing policy-related snapshots. Since snapshot do have some difference from the volume, right? Snapshot is basically a read-only thing, and they seem to have more common use cases related to sharing. So here I just have this idea, but it's kind of just for discussion. It's not something we definitely want to do right now. Or yes, the idea here is just we might, for snapshot, how about we allow you like many-to-one mapping. So a multiple volume snapshot can bind to the same volume snapshot content. So instead of you manually copy content many times, I don't see any like dangerous thing might happen from this many-to-one mapping. But for volume, we want one-one mapping because the data is like you can rewrite. We don't want to share it in many cases.
Well, there are situations where you don't want to share, but there's situations where you do want to share it. I don't buy the argument that volumes are different than snapshots in this regard.
Yeah, I don't think the fact that you can have safe many-to-one mapping is not really the problem. The problem is really who you can share your snapshot with, only with the intended people, not just with everybody. And this problem applies to volumes, applies to other contexts as well. So I think that's the bigger problem we need to address.
Yes, so the initial thought for me is the content can have some policy, say which namespace you allow to share this snapshot. It's very kind of basic policy. It's only like restrict which namespace you can share. But if we want to provide more like a set of sharing policy, that's probably out of scope. So I agree, we might want to have more like sharing policy, like across namespace, across for both snapshots and volumes.
Well, and I have a feeling that this whole sharing concept is kind of like P2 or lower, because it just doesn't feel like something that you need to have. It's very much in a nice to have.
Yes, I agree. Yeah. So we can just leave it here for now, since we don't have much time for like discussing this in much details, and we probably have a different discussion related to sharing and clone volumes, right? Everything. So let's go through whether we have other things need to discuss. And for creation retry policy, last time we say we need like more design. I think I will put up a separate document related to that. So any question related to retry policy? Last time we are saying, okay, we might have a deadline for taking snapshot, but we need to consider all the cases related to like time differences among different systems. Yeah.
Yeah, the deadline is certainly better than a retry policy, but it does have a lot of thorny problems.
Yes.
If you specify deadline in terms of the duration from the point where you create the snapshot, volume snapshot object, that addresses all the time difference, time zone issues. Is that viable or?
Yeah, but you can't agree on when that clock starts. That was the issue with having a duration instead of a deadline. Is durations require an agreement on when.
So the clock starts whenever I create the volume snapshot object. So as soon as I say kubectl create volume snapshot object, then that's when the clock starts. And then let's say I have 30 seconds to take a snapshot. And that 30 seconds is relative from the moment where you create the snapshot object. And
what if there's a significant round trip delay on the REST API? What if it takes 5 seconds to do that REST API? Does that 5 seconds count against your 30 seconds?
And that's a problem with Kubernetes. It's a declarative model, so eventually things happen. But that's the nature of Kubernetes. I mean, there's no guarantee that you see the object timely enough or process it, but at least it seems better than setting like a explicit deadline as far as, let's say, 12 p.m.
Yeah, I mean, I was going to say, I think the safest thing to do, given the nature of Kubernetes, is to not do a retry and to make the system record what time it actually did take the snapshot, and then if that was too late for the requester, he can delete it and try again. But you don't have to over-engineer it. Just say, hey, we'll tell you when we actually did it, and let you decide if that was soon enough. Because we're not going to make it. We're not going to there's no way to make it go faster. It's going to happen when it's going to happen.
So there are two proposals to setting this. One is like explicitly time, like 12 o'clock, right, 2 o'clock. And the other is give a period, let's say 30 seconds.
Well, or you could also just say we're never going to retry. We're going to make that the user's problem, right? Just we'll return failure. We didn't create a snapshot. Sorry. Or we created a snapshot and here was the timestamp. And if that's too late for you, sorry. In either case, you got to ask again.
Yes. So that's our current behavior. So we just try to create once.
So that's actually not a bad behavior. It's easy to understand, even if it's a little bit irritating. It at least makes sense. Anything else starts making less sense.
Mm.
And related to that point, I think one reason why these retry policies make sense is because, for example, some applications, they have some, quality of service guarantees that they only tolerate, let's say, 10 seconds of downtime. So down the road, when we want to support application consistent snapshots, we need to be enforcing that. And I'm not sure whether storage admins, excuse me, are aware of those time constraints. It's really the application owners who are aware of those constraints, and they're the ones who may have to set these retry policies.
Mm.
Yeah, I think that's the important part here is once we start enforcing some mechanism to QS the workload, that's going to happen for a short amount of time. We should have some mechanism to be able to communicate that to the storage system to say you have until this point in time to make this happen. If you don't, then we're going to continue the workload and you may end up with an inconsistent snapshot. But I'm not sure if that needs to also include if we do retries and how we handle retries, or if these can be two separate designs.
Any retry would have to be handled at that higher application level. So there's no point in having Kubernetes involved in the retry loop.
I think the reason we wanted to include it in the retry process was because traditionally Kubernetes does attempt to drive towards a certain state. Of course, snapshots kind of doesn't work well with the declarative model. But given that we would have a period of time, let's say, 5 seconds, 20 seconds, 30 seconds, within which a snapshot can be taken. If something, you end up with a network error first time you hit the API, but you have another 25 seconds to recover from it, it might be a nice user experience for Kubernetes to automatically retry during that period. Can we end up, designing that nice user experience in a sane way that doesn't make life impossible for the storage vendor or for the other components involved? I think is the question. Is the trade-off worth it, the design complexity?
Yes, I agree. So it seems like
is the retry policy a parameter in the snapshot class, or is the parameter in the volume snapshot object?
It could be in either place. So I think.
So yeah, my point was that if application owner is only the entity that is aware of this, then it should be a parameter in the volume snapshot object.
Yes.
Because admins may not necessarily know what's the application logic. So
yes,
whatever timeouts or retry policies they set may not be applicable to the application.
Right. Our initial thought would be in volume snapshots. Yeah. Unless we see a strong need to put in the class, snapshot class. But it seems like retry policy is not very quick to go, at least for now. So I think we can kind of move it to P2, and whether it's necessary to move to beta.
Yeah, because the existing behavior is at least sane, even if it's annoying. So.
Yeah. And also we have a kind of a little issue related to, okay, if you take a snapshot while PVC still not bound yet, or the volume still like not ready yet, it will fail, right? So whether we should want to retry until PVC is correctly bound, it seems like just a nice feature, but it's not very critical. Yeah. So, okay, we can leave it for just P2. And so right now it's already 10. The rest of them also not, I think, very critical is some nice to have feature, but we can discuss in the next meeting. Any other like issues before we want to end the meeting? Any features we missing, like you think we are missing? You can always like put your comments in the document. Okay, thank you very much. I think we kind of decided a few important features we want to have so far, and we should more focus on those, and then we'll can discuss some other things next meeting. Yeah. Okay. If there's no other issues, so we can stop now and see you next week. Thank you very much.
Thanks, bye.
Thank you.